Yes, class, am I audible? Sufyan, Taha, we have to start
Yes,
with the
ma'am.
second chapter. Okay. See, basically, we have electric potential and capacitance now present. So, electric potential is an important concept. One thing I remember, I asked Taha, okay, his network, okay. Sufyan, your syllabus was left. You know, your syllabus was left now when we were discussing. Sufyan, let me know your syllabus. Accordingly, I'll prepare then. Fine, electric potential is basically the work done only. Now you have to know what is the concept of work done. Work done is basically force into displacement. Fs cos theta, which is constant. Now work done is F dot x. So if you have a variable force, then you use the second one, F dot x, integrating it from x1 to x2. And if you have a constant force, then you use F dot L, that is Fs cos theta. Now see class, work done is this. All right. Now what is potential? Potential is also a type of, you can say scalar form of electric. Electric field was you have a charge, and around this charge you have scalar form is called the potential, which is the scalar form. So here also this will be your source charge. And you will bring one charge to check whether the electrical properties are being experienced or not. So this is called the test charge. These are being experienced or not. So basically it's a property of a single charge, and we take the difference in the potential. Now see, if I have a point, this is infinity, and this is a point which is a point. And now I have a charge which is plus q. Now, if I bring this plus q from see, this a point is there. If I'm bringing it from infinity to this point a, so I can say that work done is the change in potential is basically the work done per unit charge. To bring this charge from a point at infinity, we are bringing it to a point. So this difference, this is called the potential. Okay, this is the potential that will be coming. So what you can say, change point A per unit charge. All right. So if you have to write what is the complete, you can say the formula for work done. Work done, then we can write as potential, change in potential multiplied to the charge. And how can you write the change in potential? Work done from infinity to a point can be final potential minus initial potential multiplied to the charge. So this is important, what you have to remember. All right. So what is electric potential? Electric potential, it is the work done in carrying unit positive test charge from infinity to a point against the electric field and without acceleration. Against the electric field and without acceleration. This you should remember. It's a scalar quantity. SI unit is volt. You will be using volt. All right, not joules, coulomb. You will be using volt. Write it till here. Start writing. Taha, your net is fine. Taha, are you now able to hear? Taha?
Yes, ma'am.
It's better. Start writing. Taha, while writing, if you have any query, please Okay, class. Now the next thing that we have is electric potential for a point charge. See, we have seen that electric field also due to a point charge. We have seen electric force also due to not a point charge, basically due to 2-point charges. So likewise, electric potential is also there for a point charge. So what we'll do first, we'll use Coulomb's law. So if I have two charges and I use Coulomb's law, it is K capital Q. My second charge is small q. And what is the separation between them? X square. So which law is this? This is our Coulomb's law. Right? This is our Coulomb's law. Now see, we have work done as force into displacement, right? So force getting multiplied to displacement. This is what with I had started the class, right? So force into displacement is present. Now, what is our external force? Force is K capital Q small q by x square, right? And this is dx. And now we have to integrate it from 0 to r. So when we integrate this, see kq by x square is there and dx integrating it from infinity, so not 0, infinity to r. Why? Because we are bringing a charge from infinity to a point A which is separated by R. Okay, that's how you have to perform the derivation also. Now class, you have to solve the CK, capital Q, small q. These are all constants. So we are just left with 1 by x square dx infinity to R. Minus sign is also here. Now look, I can write x 1 by x square as x to the power minus 2, right? So when I perform integration on this x to the power minus 2, it will be plus 1 here divided by minus 2 plus 1 here, integrating it from infinity to r, and the constants minus k capital Q small q. So this is equal to 1 minus 2, this is minus 1, this is minus 1. So minus 1 into minus 1 becomes plus. So k capital Q into small q, and this is 1 by x, right? From infinity to r. Let us substitute the values. So this will be k capital Q small q. This is work done, right? 1 by r minus 1 by infinity. Class 1 by infinity is always 0. Have this in mind. So this term becomes 0. If work done is equal to, see, work done is equal to K capital Q small q divided by R. And we have seen potential is equal to work done divided by charge. So potential will be equal to K capital Q small q divided by R. That is the work done divided by charge. Charge is Q. So what is the formula? V is equal to KQ by R. This is our formula, which we can write further as V is equal to Q by 4 pi epsilon not R. This is how we can write the formula. Understood? Once we are integrating this, all the constants are on one side and 1 by x square is integrate this. Now rules for integration. X to the power n is there. You add 1. So we have added 1. And you divide it by n plus 1. So we have divided it by minus 2 plus 1. We are left with 1 by x. Put the upper limit first minus the lower limit. So 1 by r first minus 1 by infinity. 1 by infinity to 0 ho gaya. Now we are here left with v is equal to k q by r. And k we already know, k is equal to 1 over 4 pi epsilon. Positive charge, we'll be using positive potential. Plus q by 4 pi epsilon naught r. For negative charge, minus q by 4 pi epsilon naught r. Right? Tell me, this is clear? I've repeated also. Any doubts? Is it clear, both of you?
Yes, ma'am. Yes, ma'am.
Okay, good then. Write it. Then we See class, like this question, we have the charge as minus 3 millicoulomb. Means minus 3 into 10 to the power minus 3. Now here class, you will not be ignoring the minus sign because it's a scalar quantity, right? So you need this minus sign. And what is the distance? 9 millimeters. So milli you have to convert 9 into 10 to the power minus 3 meters. So potential is kq by r. Potential is equal to 9 into 10 to the power 9. Charge is minus 3 into 10 to the power minus 3. Radius is 9 into 10 to the power minus 3. 9 got cancelled. 10 to the power 10 to the power minus 3 got cancelled. So potential is equal to minus 3 into 10 to the power 9 voltage. Write it. Then we'll do for n number of charges.
Let me show it up. I lost charge.
This part, Sufyan?
Yeah.
Okay.
No.
Okay, class. So for n number of point charges you have, you will be using superposition principle. Now, since this is a scalar quantity, you don't need to actually vectorically add it, right? It's a scalar quantity. So you just can add it directly. So if I have this net potential, this is equal to V1 plus V2 up till, keep on adding it up till Vnth. Okay, like this. So for a system of n interacting point charges, electric potential at a point is algebraic sum of potential due to individual charges. Now, if you have 2 points, when you are bringing one charge from A point to another point, you write the potential as VB minus VA, right? You write it as VB minus VA. Now, work done is equal to charge into potential, change in potential. If this is actually the work done by the external field. If electric field is asked, then just put a negative sign. Multiply it with -1. That's the, okay. Write it, then we'll discuss this question. Write this. See class, in this question, two charges are given, plus 10 volt and minus 20 volt. You have to calculate the work done by the external force in carrying electron. Now see what is the change in potential. Final potential minus initial potential. Final potential is minus 20 minus initial potential is 10. So this is equal to minus 30. What is the charge? It's written electronic charge. So electron is there, so it is negative, right? Not positive. So this is minus of, that is minus 1.6 into 10 to the power minus 19 coulomb. So work done is basically change in potential into charge. It is minus 30 into minus 1.6 into 10 to the power minus 19. So this is equal to plus C. Automatically this will become plus. When we are calculating, this will become plus. And then we have 1.6 into 30. So 3 is 48. So 4.8 into 10, 48. So it will be plus 48 into 10 to the power minus 19 joules. Write it quickly. One more question we'll discuss. See, when you have to calculate the work done by electric field, these are the two charges. So when you are calculating the potential, it is 15 minus 5, which is equal to 10 volt, right? And charge is also given as 2 coulomb. So work done by the external force is very easy. You just multiply the charge with the potential, that is 20 joules. But when you have to calculate work done by the electric field, then you have to write the negative of it. Negative of work done by external, which is equal to minus 20. That's it. Write it. One more question we'll see. See class, here when you have to calculate the potential at the point O at the center, a square is mentioned. Fine. So firstly, forget that red lines which are making this. Just these four charges are present at the corner. So what is this separation? See, if I write the half of the square, means A point, C point, B point. This is A, this is A. So what this will be? This will be root 2A. So half of it, if I need it from point O, it will be A by root. That's what has been. Now from the center O, we'll calculate the potential. We know the formula is KQ by R. So see, VA will be K. What is the charge? Charge is E. See, R formula is KQ by R. We have to put everything onto this formula. So K is there. What is the charge? Charge is E. And what is the separation? A by root 2. What about B? B is minus E. Charge is minus E. So K into minus E by A by root 2. What about the third charge C? It has the charge 2E. So this will be K into 2E by A by root 2. And what is VD? This is minus 2. So K minus 2E by A by root 2. Tell me, this is clear? KQ by R. KQ by R. R means the separation from the point at which you need the potential to the charge. That is your A. Okay, that is your A. Like A by root 2. From the center towards the charge, it is A by root. So that you will be needing. Okay. So now when we are calculating the net potential, we add all of these. So see what we'll get. This is KE by A by root 2. This is minus KE by A by root 2. They'll be cancelled. What is this? Plus 2E K by A by root 2. What is this? Minus 2E K by A by root 2. These will be cancelled. So the answer of the question for the first part, net potential is 0. Now come to this class, second part. This E is made. Now what the difference will come here that you have to focus on is, see, this is point E, this separation is A. This separation is A. We need this. Class C, sorry, not A by 2. Total is A, so half of it will be A by 2. So this is A by 2, this is A, and we need this. Why? Now we'll be calculating everything from point E. So we'll be calculating plus E from point E, right? So this separation we require. Minus E from this. So this E, we require this separation, but we know this is A by 2. Then this separation, A by 2. Then this separation we need. So basically we need these separations. So what we'll do, look here class. This is A by 2, this is AE. So we'll use our Pythagoras theorem, under root A square plus A by 2 whole square. What is A by 2 whole square? It is A square by 4. That's what has been written. So answer is A root 5 by. Now what? Same thing. See, for the all the charges, if we have A root 5 by 2, this is our separation. Look, if I'm calculating the charge E from point A, so this is K, Q means E divided by A root 5 by 2. What about this charge K? Charge is minus E divided by A by 2. What about this K? What is the charge? Q, 2E. What is the separation? This also is A by 2. What about D point? K minus 2E divided by A root 5 by. Taha, you tell me again, what should be the potential at point E due to this charge? Yes, Taha.
Oh, yes, ma'am.
Yes, what will be the potential at point E? I have told all the potentials. I'm just asking you to repeat one of them. What will be the potential at point E due to this negative charge minus?
A by root 2.
A by root 2, that will be the potential. What is the formula of potential? I have repeated it so many times. I have done the first part myself. What is the general formula of a potential due to point charge?
V is equal to KQ by R.
Exactly. Now substitute. You know KQ by R. So now substitute. This is our charge. This is the separation. So what should be the potential, Taha? Start what you have told me right now. Start with that. What is the first thing which you have said? Potential is equal to
KQ by R.
K. K will come KQ. What is Q here?
Charge. E minus 1.
Minus E. So K into minus E divided by R. What is the separation here?
A by 2.
A by 2. That's it. So K into minus E divided by A by 2. Like this. Now clear, Taha?
Yes, ma'am.
Okay. Sufyan, you tell me for the point minus 2E. This point. D point. Sufyan.
Minus, no, actually, minus KE by
Minus K.
minus 2KE by
KE divided by
root 5 root 5A
A
by
root
2.
5 by. Very good. Good. So you have understood now. So these are all the potentials. Now when we'll add it, this 2 has been shifted above. So 2KE by A root 5 minus 2KE by A plus 4KE by A minus 4KE by A by root 5. The same things which we have discussed. This part Taha answered. This part Sufyan answered. So the same thing. Now, here we'll take 2KE by A common. We'll be left with 1 by root 5 minus 1 plus 2 minus 2 by root 5. So here, after subtracting it, we have finally 2KE by A into 1 minus 1 by root 5. Now, if we are supposed to calculate the work done, in work done, we multiply the potential with the charge. So 1E will be multiplied here. So that's why the final answer for work done. See, this will be the work done. Work done will be 2KE square by. Just one more thing, then you can copy it down. See the graph we have studied. We have studied till now from the starting that force is equal to KQ square by R square. We have studied electric field is equal to KQ by R square. And recently now we have studied potential is equal to KQ by R. So if these are asked to draw on a graph, because both are for point charges, then how will you differentiate it? Because both the formulas are almost same. There's just a difference of 1 R in the denominator. So the graph of electric field will be a little steeper because it has a stronger power of R. That's it. Okay. Write it down. Then I'll start with equipotential surface. Start writing from here. Okay, Sufyan and Taha, as I told you that this will be a 2-hour class, so take a 5 minutes break. Stay connected only in the meeting, but at exactly after 5 minutes, I'll start with the class. So you can just stay in the meeting. You can leave otherwise, and then after 5 minutes, I'll then start with equipotential surface, the next topic.